Today we're going to review the problem-solving process. Let's go ahead and begin. So the first thing whenever you get a word problem, the first thing you want to do is go ahead and look at the question. You want to skim the problem, find the question, and then restate the question in your own words. So here we have the first problem. Maria has $60. She bought a t-shirt that normally cost $30, but was on sale for half price. She also bought a pair of pants that was on sale for $10 off. Before tax, her total cost was $40. What are the regular price of pants? So we want to identify the question. The question here would be, what was the regular price of pants? So what we want to do, now that we found the question, is restate that question in our own words. So what are we looking for? Regular price of pants. The next thing we're going to do is identify clues. We're going to reread the entire problem carefully and mark any keywords and numbers. Then, what we'll finally do is interpret the clues and organize them. So, Maria has $60. She bought a shirt that normally costs $30, but was on sale for half the price. She also bought a pair of pants that was on sale for $10 off. Before tax, her total was $40. What was the regular price of pants? So again, we're looking for the regular price of pants. That is our question. What we want to do is identify what clues we got. Well, we got that in total she bought a shirt and a pair of pants, and the total amount she spent was $40. So the total amount she's going to spend, even with the sales, is $40. The next thing we learned is that the shirt cost was normally $30, but it was half price today. And then we saw that the pair of pants she bought was on sale for $10 off. Again, we're looking for the regular price of pants before those $10 off. So now that we have identified these different clues, what we want to do is list out what we were told. So we told the shirt is half of the $30 original price. We were told that the pants from the original price P, which we're going to look for, was $10 off from the original price. And we're told that the total she spent when she bought the pants is $40. Great. Now that we know that, we're going to go ahead and define the unknown variables. The unknown variables we're looking for is P, the regular price of pants. So now we're going to write an equation for this. And we know she bought a shirt and a pants, and we know her total, and so we want to go back and find the regular price of those pants. So we're going to use this equation. Once we see this equation, we're going to go ahead and solve the equation. So what that's going to look like is we're going to do one second. So we're going to see if we can simplify one side in order to get P by itself and solve for P. So this is a multiplication, which gives us 15. There's nothing to do in this parentheses, so we can eliminate them. Combine like terms, 15 plus 10 gives us 5. We still need to further isolate the P, so I'm going to do minus 5. And there I get P is equal to 35. Now if I want to go ahead and check this, what I can go ahead and do is plug it back into our original equation and see if it fits. So I'm going to plug 35 in back to the original equation. Which would mean putting 35 right here. Oops, sorry. That's fine, okay. 35, and then solve. So again, parentheses first, 15 plus what is the parentheses here? 35 minus 10, which gives me 25. Add those together. And thus, those two match. So that is in fact our correct variable for P. P is equal to 35. So that's the regular price of pants. Now, the next thing we're going to look at is translating from words to algebra. So there are different phrases that we have whenever we have word problems, and those words can help us identify what we need to do, when we need to add, when we need to subtract, multiply, divide, when things are equal to each other, when things are less than each other, or equal to or less than, greater than each other, greater than or equal to, and when we have some number or unknown variable. What we're going to do throughout this course is identify and be able to translate from these words, but that's going to take some practice. But let's kind of look at an example of us having to go from the words to algebra. So here's an example problem. We're going to continue with the problem solving steps. The first thing we're going to do is identify the question. In 4 years, Lee will be 3 times as old as she was 2 years ago. How old is Lee now? So the question is, how old is Lee now? So what we want to do is write that in our own words. So we're looking for L, Lee's age now. The next thing we want to do is identify various clues that can help us solve this problem. So this says, in 4 years, Lee will be 3 times as old as she was 2 years ago. So now that we've done that, we are going to interpret the clues and organize them. Well, 4 years ago, in 4 years means in 4 years from her current age right now. So this will look like L plus 4. In 4 years, she will obviously be 4 years older than she is right now. Lee will be 3 times as old. So 3 times as old as she was 2 years ago. So 2 years ago from now, which means her current age minus 2. So now what we want to do is see if we can create a problem out of this to find how old she is now. Well, what we can actually do is identify that in 4 years she will be, so is equal to, three times as old as she was 2 years ago. So we can actually create an equation out of that, and that will look like L plus 4 is equal to 3 times L minus 2. So Lee's age 4 years from now is equal to 3 times what Lee was 2 years ago. That's basically what this equation is saying. So now that we have this, what we want to do is identify a strategy to find L, how old she is right now. And so what we're going to do is we're going to go ahead and use our algebraic process to solve for L. So that will look like 3. So that'll give us a 3L minus 6 is equal to L plus 4. And what I need to do is further isolate L. So minus L, which gives me 4 is equal to 2L minus 6 plus 6 10 is equal to 2L divide by 2 divide by 2. L is equal to 5. So Lee's current age is 5 years old. So that's what we got out of doing this. But what we want to do is go ahead and check that. And the way we would do that is by plugging in 5 into our original equation. So I'll rewrite this. Oops, sorry. My pen messes up sometimes. 3L minus 2. Okay, now I'm going to plug in my L, which is 5. Sorry. So 5. Again, do the same algebraic process. So 15 minus 6 is equal to 5 plus 4, which is 5 plus 4 is 9, which is equal to 15 minus 6, which is 9, and 9 is equivalent to 9. So we did in fact get the right variable. Wonderful. So as you saw, we did go ahead and check our work. The way that we check our work is to use the process to check your work after solving a problem. The first being, reread the original question. So we reread the original question and see if we were actually answering what we were being asked. We were being asked to find Lee's original age, or age right now, and so that's what we did. We did find Lee's age right now. Then we compare the answers and the clues and see if it's reasonable. Is it reasonable that she is 5 years old? Yes, that's a reasonable age. And we're not getting something like a decimal, which is like 5.2. You can't be 5.2 years old. You have to have a whole number. And so 5 is a reasonable age. And then use another strategy to check your answer. And so what we did was we plugged 5 in and used that strategy to solve. Now what we're going to do is answer one more question from beginning to end. And as we do this, we're going to use each of our problem-solving processes. So here is the example. Steffiana can row at a rate of 12 miles per hour in still water. It takes her 2 hours to row upstream from the bridge to the park. She then rows back to the bridge, and it takes only 25 minutes. Find the speed of the river current. So we're asked to find our question first, and we can reword it, or this is just the best way to say it. Find the speed of the river current. So looking for the speed of the river current. Now we're going to go back and look for our clues. So what clues were we given? We were told that Safina can row at a rate of 12 miles per hour in still water. So her rate is 12 miles per hour in still water. So when there's no up current or down current, just still water. It takes her 2 hours to row upstream from the bridge to the park. And it takes her 24 minutes to row back, so downstream. The opposite of upstream is downstream. So when she rows back, she is rowing downstream. So we're trying to identify is to be able to find the rate of the current. So we have our clues here. The rate that she travels in still water is 12 miles per hour. She takes 2 hours to row upstream and 24 minutes to row downstream. So what we want to do is find the speed. And the way that we'll find the speed is we'll take the rate that she normally travels and the time to find the speed of the current. So what we're going to do is we're going to split our variables into upstream and downstream because we have different variables for both. And what we're going to do is first identify the rate. So the rate upstream would be 12 minus x, because as she's going upstream against the current, she is going against the current, so she's subtracting. Downstream, on the other hand, would be adding to the current and going with the current, so we're adding. And then we're given the time. Whenever she rows upstream, she does so in 2 hours. And whenever she goes downstream, she goes 24 minutes. But what we want to do is make sure that all our variables match so we're not getting confused. So what we're going to do is change the 24 minutes to hours. You could also change the hours to minutes, but it's easier to go from 24 minutes to hours. And so what we're going to do is we know that in 1 hour we have 60 minutes. And so 24 minutes of an hour she only rode 24 minutes in an hour, is equal to 2/5 of an hour. So we'll replace this with 2/5 in an hour. Okay, so now all of our variables match. So now what we want to go ahead and do is use this information to create a problem to solve the question. So our strategy. Well, we know that the distance from the bridge to the park is the same as the distance from the park to the bridge. What exactly does this mean? Well, as you can see, it says that it takes her 2 hours to row upstream from the bridge to the park. So let's say we have a bridge here, and then we have a park. Okay, so what it's saying, let's say there's a stream here, and she takes 2 hours to go upstream. So let's say this is upstream. This takes her 2 hours. And then when she rows back, that's what it says right here, right? Rows back, then she rows downstream. But that takes her 2.2 out of 5 hours. So the distance is the same. So what we want to do is put the equations together, the distance equations, right? Distance is equal to r times t. Distance is equal to r times t. We want to equal those together to find the speed of the river current. So that'll look like, and I'll do it right here, r1 times t1 is r2 times t2. r1 is times 2 equals 2/5. And so what we want to do is find x, where x is the river, the speed of the river current. So the way we're going to do that is I'm going to go ahead and distribute this into these, which will give me 24 minus 2x, which is equal to 12x 5, okay? And so I want to do that to this side as well, and that will give me there, okay? But what I need to do is get rid of those fractions so that this is easier to solve, and the way that I'm going to do that is I'm going to multiply by 5 on each side. So multiply by 5 on each side, right? And that allows these to cancel out. And so that gives me 120 minus 10x equals 24 plus 2x. And now I want to further find my x. So I'm going to do minus 2x minus 2x, which gives me 120 minus 8x is equal to 24. Okay, I'm going to subtract the other side, which gives me, oh, that's not 8, it's supposed to be 8, it's supposed to be 12. Because a negative minus a negative equals you add, so negative 10 minus negative 2 is negative 12. So this is where we end up, still same thing. So cancel that out. So 24 minus negative 120 is, I'm going to put it over here, negative 96. Everything else comes with it. But I need to further isolate my x. Okay. Allows me to cancel that out. So x is equal to negative 96 divided by negative 12, which is equal to 8. So x is equal to 8. So the speed of the river current is 8. But what I want to do is check this by going ahead and plugging it back into the equation. Okay, so my original equation was okay. Now I want to go ahead and plug in the 8. So I'll do that. Plug in 8. We need to do it in the parentheses first. So that will give us 12 minus 8 is 4. 12 plus 8 is 20. Now we want to multiply. So that gives us 8 equals, multiply here as well, which gives us 8 as well. So 8 equals 8, which means that we did in fact find the correct rate or speed of the river current. Okay, so basically what we went over today is we looked at how to go about solving a word problem every time. So the first thing we want to do is deal with the question. We skim the question, find the question, state the question in our own words. The next thing is clues. We want to reread the entire problem carefully, mark keywords and numbers, and then interpret the clues and organize them. After that, we find a possible strategy for solving this equation by writing an equation, and then we go about solving the equation. The next thing we want to do is go about using the check if our problem is right. So we want to check our work. So the first thing we're going to do is reread the question. We're going to ask ourselves, did I answer the question that needed to be answered? Then I'm going to look for the clues. I'm going to compare the answers and the clues. Is our question reasonable? And then finally, the last thing I want to do is use another strategy to check my answer. So that's whether by plugging in what I solved for and seeing if those two equal each other, or going about using a different strategy. Either way, what I want to see is, do I need to revise my solution? Do I need to do something again because something didn't end up matching up? So is my solution plausible? So basically, that is the different ways that we go about looking at word problems, and this is something to keep in mind as we move throughout this course.